This question looked impossible, and then my student figured out how to do it, and he said it's his favorite question he's ever solved. Now, we did a detailed breakdown of introducing the question yesterday, but let's just take a quick recap about what this question's actually asking. So it's asking how many ways is it possible to get a gorgeous grid which has 9-digit multiples of 9 across every row, down every column, and along the two main 9-digit diagonals. Now there's one constraint here. So for example, 3, 4, 5, 6, 7, 8, 9, 1, 2. But it doesn't have to be the same from row to row, and it doesn't have to be a pattern between the rows either. This is an incredibly complex question when we get started. We're gonna have to try and build our intuition about where this problem's gonna go, and what kind of insights can we find along the way that are gonna help us make the question easier. Just consider the most simple examples first. What if we just had 1s all the way down the first column, and then 2s all the way down the second column? So we just went 1 to 9. In every single row. And we want to know, is this going to be a gorgeous grid? The sum of the numbers from 1 to 9 is 45, which is a multiple of 9. So 1 plus 2 up to 9 is equal to 45. And we know that for any multiple of 9, we just need to check the digit sum is a multiple of 9 for the whole number to be a multiple of 9. So therefore, the number 123,456,789 is indeed a multiple of 9. So every row will work. Every column has 9 of the same digit. So it's going to be 9 times 1, 9 times 2, 9 times 3 when we're considering the digit sum. So every column will be a multiple of 9 as well. The one that's potentially going to be tricky, especially for the more complex cases, is the 9-digit long diagonals. But in this case, we're just going to get 1, 2, 3, 4, 5, 6, 7, 8, 9. So the same as the row, which we already know works. And here, starting the bottom left, we're going to go up to from 1 to 9. So again, same as the row, it's going to be a multiple of 9. We're happy. That's our first example that we've checked. What if we move a row with a pattern? So for example, we move this row across 1, so it starts with a 2, and then this one starts with a 3, this one starts with a 4. Is that going to work? These are cases that you can try to build your intuition around the problem. Now, this is not going to constitute a proof, because like I said, we're not going to check every possible case here. It's going to take years. But what we can start to do is look for insights. By testing things systematically, we might spot something interesting and useful, something that's in common with all of the cases that we've looked at. And those are the types of things that are going to be the basis and the foundation of the solution to this problem. Drop me a follow to see part 3 tomorrow.